Okay, good morning again, everybody. So, eto na, totoo na to. So, by now, you should be able to access the first problem set, which will be due on Wednesday next week. Uh, yes, Ayesa? Or napindot lang ba yan?
Napindot lang po.
Okay, no worries. Okay, so, yeah, but before that, baka makalimutan ko na naman, I already finalized my consultation hours. So, consultation hours ko ay 9 to 11, Monday to Friday. So if you have some questions you want to or you want to talk about anything actually, academic, math 155 related or not, or kailangan nyo lang na makakausap, you can drop by the MS Teams online, my online office. Nandun sa Canvas homepage natin yung paano ka makakasali dun sa, or ano yung tawag doon, invitation code for the MS Teams for my online office. So every 9 to 11 a.m. every Monday to Friday, I'll make myself available for student consultations. If you're not free during any of these times, then you'll just need to send me an email and set up an appointment para sa mga consultations nyo. And then I'm also thinking about creating short videos kung meron kayong yung mga tanong na um, mga mabibilis na tanong that you don't think you need to meet with me personally. Pwede nyong isend sa akin via email or via chat. And then kung mahirap siyang sagutin via chat, so maybe I can record a 1 minute video, a 30-second video, and then make it available to everybody. So um, para maka-take advantage tayo ng mga technologies na available today, no? Mga tipong reels, ano? So, yung mga teachers talaga ngayon nape-pressure na maging mga vloggers dahil sa setup natin. So, yon. And then what else? Oh, I already graded the homework number 3. So, check out your graded work. Napansin ko lang kung kailan ko kayo hindi sinabing kailangan ng explanation, ang daming nag-explain, which is a good sign, all right? So, binasa ko naman yung mga explanation pero hindi ako nagbase ng grade dun sa explanations. Pag tama yung sagot nyo, perfect na kayo dun sa item kahit medyo may mali dun sa explanation ng konti. But generally, lahat naman ng explanations ay 80 to 90% tama. Okay? I mean, yun yung accuracy ng bawat isang explanation. Or, sorry, 80 to 100%. So, kinorek ko na lang yung ibang maliliit na mistakes dun sa mga explanations nyo. Pero that's great. Now I know that you really understood what you're writing. And it's a good habit to provide little explanations even if they are not needed. Okay? So, yon. Pero pag mali naman yung sagot nyo, ay, kahit may sense yung explanation, alright, nagkamali lang kayo ng conclusion or may namali lang kayo along the way, I was forced to also not give you credit for that particular item. So dun sa number 1.8 bawat isang item, so for a total of 4 points. And then yung usual pangungumusta question is worth 1 point. Okay. So that's it. And then we don't have a homework for next week because you'll be working on the problem set, which we can talk a little about today. So yan. So pwede nyo nang i-download via Canvas. Can you let me know na download nakita nyo na ba? All right. Thank you, Prince. So ito yung problem set number 1. Please read the instruction. Parang kinain na ng instruction yung first. Damn it. Mali na naman yung. Meron ako hindi na-edit. Halit. Hindi. Tama. Sorry. First sem pala itong pinoproject ko. Dapat yung second sem. Yan. Okay. So, kinain na nung instruction yung kalahati ng first page. So, basahin nyo to. Pero I want to emphasize the following points. First, the deadline is on March 23rd, 11:59 p.m. sa Canvas. And then dun sa mga first time ko naging estudyante, pag problem sets, I make individual bins for each of the items. So pag natapos na kayo sa problem number 1, sure na kayo, wag niyo nang antayin na matapos yung ibang problems, upload niyo na siya kagad. So in that way, I can start grading, tapos mabigay ko yung feedback as soon as possible. Alright? Para hindi ko kailangang antayin lahat ng isa-submit nyo at para hindi siya matabunan. My only reklamo about Canvas ay alphabetical lagi yung papakita niya sa akin ng mga mga works that need grading. So kaya hindi ko siya ma-first come first serve basis. So the only way that I can grade your work ay kapag kayo pa lang yung nagpapasa or kokonti pa lang yung nagpapasa, kaya ko na siyang matcheckan kagad. Pero pag umabot na ng deadline, tapos bugso na yung mga submissions, nag-alphabetical na siya. So magiging yung nauna sa alphabetical order, siya yung una ko na-checkan, alright? Pero yeah, I'll appreciate it if you guys can submit early. Again, it's per numbered item. Makikita nyo naman dun sa submission bins, hiwa-hiwalay sila. There are 6 problems in the problem set, but you only need to submit 4. Actually, kailangan 4 lang yung isubmit nyo. Exactly 4, alright? So, wag nang mag-over submission, okay? So if you want to answer all problems, then you can do so. Pero by email nyo na lang sa akin ipadala yung dalawang extra problems, all right? So there are 6 problems you need to answer for. Una, si number 1 ay required. Okay, so you have no choice but to answer problem number 1, which is basically an exposition about the completeness action, all right? So kailangan niyo yan sagutin no matter what. And then pipili kayo dun sa natitirang 5 ng 3. Alright? But the only restriction is you can only choose at most 1 between problems 4 and 5. Okay? So, pipili ka ng 3 pero hindi pwedeng parehas mong piliin si 4 at saka si 5. Isa lang sa kanilang dalawa or wala sa kanilang dalawa. Okay? Bakit ganon? Kasi yung number 4 ay, kasi yung number 2, number 3 ay proving. Yung number 4 kasi ay example building. Alright? Parang yung katulad ng, wala pa pala tayong homework na ganito. So, kailangan nyo magbigay ng example without proof. So ng mga sets E that will satisfy, halimbawa si problem A. Okay, problem A, magbigay ka ng set E na ang derived set ay ito yung laman. Okay? So number B, magbigay ka ng set E na ito naman yung characteristic, and so on. So for this problem, I don't need any proof. I just look at what set E you gave. All right? And then still worth 10 points. So I guess worth 2.5 points bawat isang problem dito sa 4. Tapos yung number 5, and I think maraming maengganyo dito, true or false. Okay? No explanation or proofs needed. So and then kay Canvas, quiz type yung ginawa ko rito. So online na kayo magsasagot kay Canvas, either true or false for problem 5. And again, hindi kayo hanapan ni Canvas ng explanation. True or false lang talaga yan. So, yon. Again, dahil medyo, I think madali yung 4 and 5, at least on the surface, mukha siyang madali. So, isa lang sa kanilang dalawa yung pwede nyo sagutan. At most, isa sa kanilang dalawa. Okay. Tapos, pipiliin nyo na yung natitira kay 2, 3, and 6. Or pwede naman 2, 3, 6 na lang yung piliin nyo. Okay? Kung gusto nyong mag-prove talaga, 2, 3, 6. Huwag na kayong pumili kay 4 and 5. Okay lang yon. Ang bawal ay parehas sagutan si 4 and 5. Okay? So I think that's it. Pretty straightforward naman yung homework. Sorry, yung problem set. So just let me know if you have any problems later. So sufficient ba yung time? So you have Thursday, Friday, Monday, Tuesday, Wednesday. So you have 5 working days to work on this problem set. So it's fine if you can only answer 1 problem a day. You will still be on track. Okay. Kahit hindi kayo mag-work ng weekend, but if you want to devote part of your weekend, then that's also good, right? So you have 7 or 5 days to finish the problem set. Okay. So kukumustahin ko na lang kayo on Tuesday. How are you doing with the problem set? And then let's see kung ano yung mangyayari. Okay? Any quick questions about the problem set? Tuloy yung problem set, okay? So hindi ako naniniwala sa signs. So sorry, Prince. Yan. Okay, so yeah. Take a look at it and then kukumustahin ko nga uli kayo sa Tuesday, okay? Okay, now we are ready to start the second unit of the course, which is about sequences in the set of real numbers. Now, basically, this is just relearning, re-emphasizing, or digging in deeper into what you learned in Math 38. So ito siguro yung advantage ng mga kakatapos lang ng Math 38 last semester, right? Yung mga maagang kumuha ng 155. Because most of the things that we are talking about, at least yung computational aspects nila ay fresh pa sa inyo. So I assume that you still remember how to find limits of sequences, ano yung mga criteria para masabi ng isang sequence ay convergent or divergent, and so on. Because that's where Unit 2 will revolve. So pag-usapan natin yung mga sequences of real numbers, what are they? And then we'll look at their convergence. Tapos, ano yung pinagkaiba niya sa Math 38? Now, we will be looking at them from a theoretical point of view. Okay? So, mas malalim yung pagtingin natin about the sequences in R. So, having said that, we will not deal in computing the limit of sequences. Okay? Hindi ganun yung focus natin. So, ang focus natin ngayon ay either mag-develop ng tools para mas madaling ma-check kung ang isang sequence ay convergent or not, regardless whether we will find the limit of the sequence or not. And we will try to tie this up into or tie this with the properties of sets or subsets of real numbers that we talk about from unit number 1. And then also, we will develop it in such a way that it will be our springboard for defining the limit of a function. So medyo ipapakita ko sa inyo ngayon yung isa pang side ng limit ng isang function. Kasi sa Math 30 series, define yung limit ng isang function to be, you look at for all epsilon greater than 0, there exists a delta greater than 0, such that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. All right? So yun yung mahabang definition ng limit ng isang function. Pero hindi lang ganun yung paraan para ma-define yung limit ng isang function. There's an equivalent way of doing it, but this time it's using sequences of real numbers. So ito yung kabilang side na gusto kong ipakita sa inyo in Math 155. Kaya ang unit 2 natin, di tayo pumunta kagad sa limit ng functions. Sisimulan natin sa sequences. Tapos kakaiba to kasi sa Math 30 series, sa Math 38, dinefine yung limit as ang sequences as functions of as a function whose domain is the set of natural numbers. Okay? So tapos mula doon, nakuha natin yung mga theorems or nakihitch siya dun sa mga theorems na alam na natin that works for functions. Kasi sabi natin ang sequences, special case lang naman yan ng mga functions. So kung ano yung properties ng limit ng isang function, dapat may corresponding analogous version yon para sa limit ng sequences. Ganun yung development sa 30 series. Pero ngayon, titingnan natin, baliktarin natin yung development kasi it really makes sense to start with sequences. Kasi sasabihin ko ngayon, ano yung definition ng isang sequence. Tapos dahil wala pa tayong notion ng function, hindi ko siya i-define as a function of natural numbers. Or will I? Sorry, nakalimutan ko ano yung simula. Pero yun yung idea. Magsisimula tayo sa sequences. Titingnan natin yung properties ng limits ng sequences in specifically its convergence, tapos ano yung mga pwede natin paglaruan about convergent sequences, i-prove na natin yung mga properties na yon. And you will see later that this will pay off when we talk about limits of functions. because I will define the limit of a function in terms of sequences or limits of sequences. So lahat naman ng mga properties ng limits ng sequences ay makikarry over pagdating natin sa functions. Okay? Makikita nyo, ganun ka-flexible yung mga theory, right? Or yung mga axiomatic systems. So, pwede tayo come up with a very different approach to the same thing by just picking out ano yung i-define natin sa simula. So that's why it's no wonder that the discovery or the invention of calculus was attributed easily to two persons who work independently. Kasi napaka maraming paraan para ma-develop yung calculus. So kaya nga kahit si Sir Isaac Newton yung mas sikat nung 1600s, nung sinabi niya na na-discover niya yung calculus, there was a dispute from von Leibniz from Germany, okay? And then mathematicians agreed that they work on the discovery of calculus independent of each other. So they were credited both for the discovery of calculus kasi nga yun, depende kung ano yung i-define mo muna. Newton might have defined calculus and started with derivatives, while Leibniz started working with integrals. And interestingly, they were able to meet in the middle. Parehas lang yung theory nilang na-develop. Okay? So, sisimulan natin yung discussion ng Unit 2 with concepts that you already know. So, medyo magaan lang yung lecture ngayon. Parang recall lang siya ng mga natutunan natin before. Okay. Hindi pala totoo yung sinabi ko kanina na i-define ko yung sequence different from a function. Pero yung pala yung gagawin ko rito. But the nice thing is, wala tayong properties ng limits ng functions pang gagamitin para masabi or ma-compute yung limits ng sequences. Okay? So usually it's either an intuitive analysis of the terms of the sequence itself or magpo-prove tayo ng mga theorem para sa kanila. Okay? So of course, let's define first what a sequence is. All right. So a sequence is indeed just a function from n to r. So because for every natural number, we assign a real number, then we get a sequence. Okay. And then the number, if your function is defined to be f, so basically we're assigning a natural number n to a real number a sub n. And we say that a sub n equals f of n is the nth term of the sequence. Okay? So basically, since ang domain niya ay set of natural numbers, and we can nicely list the elements of the set of natural numbers, then that will transcend into the terms of our sequence. So kung halimbawa, magde-define ako ng function na ang domain ay n, halimbawa f from n to r. Okay, so by the way, this symbol means f is a function whose domain is the set of natural numbers and whose codomain is the set of real numbers. And then if I say my formula is, say, A is mapped to, N is mapped to 1 over N, okay? So that means f of N is equal to 1 over N. Tapos si 1 over N, siya yung N term natin dun sa sequence. All right. So some common ways to represent or to write a sequence or to define a sequence is either using a formula like this. So we're giving the formula, the generic formula for the n term of our sequence, or we simply list the elements of the sequence. All right. So if n is equal to 1, plug it in here, we get 1. If n is equal to 2, we'll get 1/2. If n is equal to 3, we get 1/3, 1/4, and so on. So basically, in the illustration, the first number or the first example is the listing of the members of this function f or this sequence f. Okay. But when we write the sequence as a list, it is with the understanding that dapat ordered listing yung ginagawa natin. So for instance, the sequence that we have in number 1, the sequence 1, 1/2, 1/3, and 1/4, if it is clear in context that you're talking about the sequence for number 1, so kung klaro sa ating lahat na ito ay hindi set, hindi lang siya basta set, siya ay sequence, then we can say that this is not the same as 1/2, 1, 1/3, 1/4, and so on. All right? Because again, when you are writing down the elements of a sequence, the ordering matter. Okay? So, kung silang dalawa ay sets lang, and then, okay, they are equal. Pero kung clear sa context ng problem na sila or ng discussion na sila ay nag-stand for sequences, then these two guys are different sequences. Okay? All right, so can somebody enlighten me or to tell the class bakit hindi sila equal as sequences? Sige nga, bakit hindi sila equal as sequences? Kahit na parehas yung laman nila. Pinagbaligtad ko lang yung first two terms. Yes, David?
Sir, di ba po yung first sequence pwede natin i-represent gamit 1 over n? If we use the one na nasa right, hindi na po siya represented by 1 over n. So magkaiba na po sila.
Right. Thank you, David. Because again, so sequences ang understanding natin yung una, siya yung function value ni 1. Yung pangalawa, function value ni 2 and so on. So clearly, tama si David, ito ay representation ng 1 over n. However, you cannot do that here because hindi na siya representation ng 1 over n kasi yung first element niya ay hindi na 1 over 1. Okay? So basically, yeah, ito yung function value, ito yung f of 1, ito yung f of 2, ito yung f of 3, and so on. But definitely, this is not f of 1. So basically, the second, the right-in set here, the right-in sequence here is not a representation of 1 over n. Okay, so medyo may abuse of notation here. Ginamit natin yung same symbol as sets, but again, it should be clear in context that we're listing down elements of a sequence. Okay? So, meron pang isang hybrid ng pagsusulat ng pag-represent ng sequences, that is by enclosing in braces yung formula para sa n term. So, pwedeng ganito, 1 plus n over n, where n goes from 1 to infinity. So, pwedeng ito yung notation. But sometimes, I'm also fine writing the sequence this way, 1 plus n over n. So pag clear naman sa context, instead of putting the subscript and superscript here, pwede nyo na siyang i-drop as long as it is clear that we are talking about sequences. Okay? Tapos kung gusto mong makuha yung listing ng elements ng sequence na to, then you plug in order the natural numbers, actually in increasing order. N equals 1, n equals 2, n equals 3, and so on. Okay? Pwede rin namang a sub n yung ilagay nyo dyan, tapos nakadefine sa labas ano yung formula ni a sub n. Okay? Tapos yung pang-apat, this is a nice example of a recursive sequence wherein the computation of the n term depends on the computation of the previous terms. Alright? So yung mga nagwa 175 dyan, familiar kayo sa iteration formulas, right? Iteration schemes. Parang ganun yung pang-apat. May mga sequence na para ma-compute yung n term, kailangan mo yung n minus 1 term or even some more previous terms. Okay? So dito sinabi ang x1, okay? Yung x sub 1 siya yung function value ni 1. So siya daw ay si 2. Pero para ma-compute yung x sub 2, kailangan kong gamitin itong formula na to. And there's still a typo here. Yung plus 1 dapat subscript siya. So yung x sub n plus 1 ay equal kay x sub n plus 1 over 2. So that means to get x sub 2, so ibig sabihin x sub 2, n is equal to 1. I'll have x1 plus 1 all over 2. So we'll get 1. All right? Tapos, para ma-compute si x3, kailangan mo si x2. So that's gonna be x2 plus 1. Tama ba sinulat ko kanina? So x2, 2 plus 1. Sorry, mali pala yung x2 ko. Dapat 3 halves. Okay. Because it's gonna be 2 plus 1 all over 2. So that's gonna be 3 halves. And then we'll have, para ma-compute yung third term, kailangan kong i-plug in yung second term dito. 3 halves plus 1. That's going to be 5 halves divided by 2. So that's 5 quarters. and so on. Tama ba yung substitution ko? Hopefully tama yung substitution ko. Pero yun yung idea. Kailangan na gamitin yung mga previous values dun sa current para makuha yung yung end term, yung bagong term dun sa sequence. Okay. There's a nice example of a recursive sequence, and yun yung Fibonacci sequence. Have you guys heard of the Fibonacci sequence? Siya yung nagsisimula sa, pwede siyang, or actually marami pala siyang definition, no? So pwede siyang 1, 1, 2, 3, 5, 8, 13, and so on. All right. Wherein the nth term is the sum of the last two terms. So, pero kailangan ko ng initial condition. Kailangan kong initial condition is si 1, 1. Okay, usually, pag nag-iba yung initial condition, pwede ka pa rin makakuha ng Fibonacci, pero if you continue the pattern, pero iba-iba na yung terms natin. So, yun yung mga Fibonacci sequences. But I guess the most popular initial conditions for the Fibonacci sequence ay yung 1, 1. Tapos para makuha yung third term, just take the sum of the previous two. So 1 plus 1 is 2. And then to get the next term, add the last two terms. 1 plus 2, that's 3. Then 3 plus 5, that's 8 and 13. And you will see that by design, yung terms ng Fibonacci sequence will eventually increase without bounds. Padagdag kasi ng padagdag yung nasa terms ng sequence. Okay? So essentially, a sequence is an infinite list of real numbers. Okay? Hindi nga lang infinite list. It's an infinite ordered list of real numbers with a caveat that infinite list siya, pero pwedeng may mga maulit dun sa listahan. That's another feature of sequences, especially if we write it in a list form na different from the usual set notations. Okay? Kasi limbawa, pwede kasi ang sequence natin ay i-define ko na f of 1 is equal to 1, sorry, not f of 1, but f of n is equal to 1 for all natural number n. Ito ay isang function because for any distinct input, I get one output. Tapos ang domain niya ay natural number. Yun nga lang, ang function value ng lahat ng natural number ay equal kay 1. So if I list down the elements of this sequence, I'll have 1, 1, 1, 1, 1, and so on. Full of ones until forever. Okay? Now, sa set notation, bawal to, right? Kasi sa set notation, dapat nililista lang natin yung distinct elements ng isang set only once. Okay? But sa sequences, pwedeng pare-parehas o may mga maulit na elements. Kasi nga, essentially, ang nililista natin dito ay f of 1, f of 2, f of 3, and so on. And they are treated to be different objects. Yun nga lang, naging equal sila after evaluation. So it is an infinite list, even if merong mga repeating, elements or entries doon sa listing. Okay? Now, another thing that is different from sequences, but this time for functions or from functions, ay yung graph ng sequence. And I still find it done by some students, okay? Especially at the beginning of the course. Kapag ka nag-analyze kasi tayo ng isang sequence, posible kasing, halimbawa, kumuha kayo ng graph, okay? Pwedeng ipagraph nyo siya, especially if you know the formula. Okay? Kaya lang, pag nagsasubmit sila sa akin, pinagraph nila halimbawa sa isang software, which is fine with me. You can use any technology that you have, right? Halimbawa, 1 over n. Pinagraph ko sa kanila si 1 over n. And then it is clear that I ask them to sketch the graph of the sequence 1 over n. Ganito pa yung notation ko. Tapos pinagraph lang nila. So ang ibibigay sa kanila ng mga computing software is a curve like this, which is 1 over x, where x is any real number. So for that, they will get some deductions. Kasi ang graph lang ng isang sequence ay plot lang sa Cartesian plane ng mga elements ng sequence. So kung ito si 1, ito si 2, ito si 3. So if you will present to me this graph without any explanation or without any caveat or any disclaimer na this is the real version of the function and not just the sequence, all right? You will be claiming that for 1/2, okay, meron siyang function value. So ibig sabihin, hindi na n yung domain ng 1/n. Pero I gave you a sequence with the understanding or with the implicit understanding dapat na ang domain niya ay set of natural numbers. Pag pinersent nyo sa akin tong graph na to, kiniklaim nyo na si 1/2, na si 3/2 ay element ng domain. Kasi nga meron siyang function value. So kung i-graph nyo yung isang sequence, make sure na ang may function value lang o yung may dots ay yung mga natural numbers. So halimbawa, ito si 1, function value ni 1 ay 1, function value ni 2 ay 1/2, function value ni 1/3, ni 3 ay 1/3, and so on. Okay? So magiging mga dots lang siya. Okay? So this would be an infinite number of isolated points. Okay? All right. So sana clear 'yon. If gusto niyo talaga siyang i-graph tapos hindi niyo kaya na dots lang talaga yung naka-graph, you can present to me the continuous graph. Pero sabihin niyo dun sa explanation niya na, sir, ito ay yung ito yung extension nung sequence as a function of real numbers. Pero apparent pa rin naman, sir, kung ano yung behavior nung sequence mula dun sa behavior nung kanyang counterpart sa mga functions na ang domain ay real numbers. So kaya mahalaga na meron kayong caption o meron kayong parang description dun sa inyong narrative, dun sa isa-submit nyo sa akin. Kung Instagram post nyo nga, nilalagyan nyo pa ng captions, pinag-iisipan nyo, no? So what more a formal academic document that you will submit to me, di ba? So, yon. Okay. Now, we are not just into the business of playing with sequences, plugging in function values, but usually the important thing about sequences insofar as analysis is concerned is the behavior of the sequence towards the tail end. Ano yung nangyayari dun sa dulo ng sequence? All right? Yun yung parang nagiging business ni analysis. Yun yung gusto nating tingnan. That's what is important for us. So basically, when I say tail end of the sequence, we will try to look at what is happening when n increases without bounds. So ano yung nangyayari pag palayo na ako ng palayo kay 1? Pag nandun na ako sa dulo ng listahan, do the terms in the sequence accumulate around a particular number? Is my sequence bounded, meaning as I go along, hindi ba ako lumalampas sa isang real number, or will I go on forever, or will it increase forever or not? So yun yung titingnan natin ngayon actually sa entirety ng chapter na to. Ano yung nangyayari kapag si n increases without bounds? Okay? And to quantify this nice behavior at the end, we will define the limit of a sequence. Okay? So what do we mean by the limit of a sequence? So we say that the limit of a sub n as n approaches infinity is equal to a. Or alternative notations for this, you can say that the sequence a sub n, so kapag ka naka-enclose yan sa braces, ang basa natin dyan sequence, so it is the sequence a sub n converges to a as n approaches infinity. Okay? Or, I love this notation more kasi mas compact siya, a sub n approaches a. Okay? So ito yung mga iba't ibang paraan para masabi natin ng limit ni a sub n na equal kay a. Or in other words, nagko-converge si a sub n kay a. So you can write the limit notation. You can write the English version. Or you can simply write a sub n goes to a. Ito ay arrow. So, kailan natin masasabi na totoo yung equation na yan? Totoo tong equation na to, totoo tong phrase na to, or totoo itong symbol na to. Okay? So, we can say so if for every epsilon greater than 0, however small it is, there will exist a natural number n such that for all little n greater than capital N, ang absolute value ng a sub n minus a ay less than epsilon. Okay. Now, that's a mouthful. And parang ang daming nangyayari sa definition, pero himay-himayin natin yung definition. Okay? Ano yung sinasabi nito? For all epsilon greater than 0, and at the back of our minds, epsilon na naman yung ginamit, so probably the interest here is to see what happens for very, very small epsilons. Okay? So let's, with that clear, let's set it aside for now. Tingnan natin yung susunod. Dapat daw may makita akong capital N. Okay, so ito yung 1, 2, 3, 4, and so on. Dapat daw may makita akong capital N. Ano yung condition dun sa hanapin mong capital N? Oh, by the way, this capital N may depend on epsilon. So sa bawat epsilon greater than 0, dapat may makita tayong capital N. So the existence of capital N might depend on epsilon. Okay, depende dun sa epsilon na ibibigay. Epsilon is the challenge. Dapat meron tayong response na capital N. Now, para saan si capital N? Si capital N, siya yung parang magsiserve as the starting point. Kasi tingnan nyo itong condition na to. Little n, for all little n that is greater than or equal to capital N. Okay? So pag lumampas na ako kay capital N, nandito na yung mga little n's. Alright? Dapat daw, yung mga little n's na yon na lampas na kay capital N, yung little nth term ay dapat within epsilon unit away from the purported limit of the sequence. So in essence, in layman's terms, ang limit ng sequence ay yung number A kung saan after some time, alright, yung mga terms ng mga sequence na ay super lalapit na kay A. Kasi nga, epsilon is a small number. Absolute value stands for distance. So that means the distance between A sub n minus A should be very small. Should be smaller than that small epsilon that you have set in the beginning. All right. Tapos hindi required na totoo yan sa lahat ng terms. Right? Hindi siya kailangan totoo sa lahat ng A sub n. Totoo lang siya dapat sa mga A sub n na yung subscript little n ay mas malaki na kay capital N. So ibig sabihin, beginning at some point, dapat yung mga terms ng sequence ay malapit na kay A dun sa limit. So that's why we said earlier that the business of analysis is the behavior at the tail end. Because if we want the terms of the sequence to be within epsilon units, okay, may makikita tayo laging starting point or starting subscript, capital N, na after that starting subscript, yeah, malapit na yung mga A sub n's kay A, they will be within the epsilon distance. And if we can do this for all epsilons, then we say that indeed the limit of A sub n is equal to A. So ibig sabihin, nagkukumpul-kumpulan na yung mga elements ng sequence around A in the tail end. So parang si A, kaya nga siya limit, isa siyang limit point nung set of all function values. Alright? So yun yung connection niya dun sa ating chapter 1. Okay, nagiging limit point siya kasi in the end, yung epsilon neighborhood, kahit anong epsilon neighborhood ni A ay nagko-contain ng infinitely many members ng sequence. Bakit ko nasabi? Kasi remember this guy? Kapag totoo tong inequality na to, ibig sabihin si A sub n ay member ng epsilon neighborhood ni A. Alright? Kasi yung distance between A sub n and A ay mas maliit kay epsilon. So instantly, si AN ay member ng epsilon neighborhood. Tapos ang sinasabi nito, sa kahit na nung epsilon greater than 0, lagi na lang si A sub n, may makikita tayong A sub n na element ng epsilon neighborhood ni A. Okay? So kaya nagiging limit point yung A. Kaya ang tawag sa kanya limit. Hindi nagkataon na magkapangalan sila or ginamit yung same term as limit points, tapos ngayon limit of a sequence. Yeah, they have some conceptual relations to each other. Kasi yung sequence, yung limit ng sequence ay isang limit point nung special set o nung listing of the function values of the sequence. Okay? So Any questions with that definition? Pero I think ganito rin siya dinefine sa Math 38, no? Yung limit ng sequence. So nothing spectacularly new about that. Okay, medyo pinalalim ko lang yung discussion. But even that explanation might have been given to you in Math 38, but it's a nice refresher to talk about that again here. Okay, so with that, let's take some looks at sequences, some examples of sequences and their limits, okay? Let's start with a simple one. That's example 1, yung limit ng 1 over n. So, ngayon wala pa tayong mga theorems para mag-compute ng limits ng sequences, all right? Pero pwede nyo siyang tingnan by a quick analysis, tapos gut feel na lang kung ano yung nangyayari as n increases without bounds, okay? So for instance, ang hypothesis ng example 1 ay ang limit ng 1 over n daw ay equal kay 0, okay? Now, how can you come up with such a hypothesis? So pwedeng tingnan mo nga yung tingnan mo yung mga first few terms and see if you can deduce a pattern. 1, 1/2, 1/3, 1/4, 1/5, 1/6, and so on. Okay? So pag dinesimal mo yan, 1, 0.5, 0.3 bar, 0.25, 0.2, 0.16 bar, and so on. Paliit sila ng paliit. So you can hypothesize na baka naman ito magko-converge sa 0 in the end. Kung hindi ka pa kumbinsido, tingnan mo yung 1 over n. Ano yung nangyayari kapag ka si n ay napakalaking natural number na? Excuse me, guys. Okay. So habang si n ay lumalaki ng lumalaki, yung fraction ay paliit na ng paliit. So you can imagine this at the back of your minds. Ano? So may isip nyo, 1 over positive infinity. 1 over a very large number. Natutunan ko na to sa calculus pero hindi ko sasabihin kay sir na gumamit ako ng calculus, alright? Na ito ay magiging equal kay 0. Okay? And again, I'm putting them in quotes kasi nga magagalit yung mga technical mathematicians, yung mga napaka-technical na mathematicians. Nakita 1 over infinity, there's no such thing because infinity is not a number. But intuitively, this is a guide. 1 divided by a very large number, that will be equal to 0. Okay, so pwedeng ganun mo siya i-analyze. Or graphically, ganun nga, pwede mo siyang tingnan. Okay, plot ko nga yung 1 over n. Ito yung itsura niya. Then bababa, then bababa, then bababa, and then bababa. Mukhang magsi-0 siya. Kung di ka pa kumbinsido, i-connect the dots ko. Kunin ko yung 1 over x na natutunan kong i-graph sa algebra at asymptotic siya sa y equals 0. So mukhang talagang palapit ng palapit kay 0 yung mga terms ng sequence na 1 over n. Okay? Pero we will not be contented with just an analysis para makakuha ng saan kaya posible siyang mag-converge. Kailangan nating i-prove via definition, at least for now, kung na eksakto talagang 0 yung limit ni 1 over n. Okay? And then usually, when proving limits, alam nyo na to, laging may preliminary analysis. Kasi ang idea rito ay mag-assume ka ng generic na epsilon, tapos dapat makapagbigay ka ng capital N. So the challenge is an epsilon that will be given to you. Okay, and epsilon can be any positive number. And the challenge is to give a natural number capital N. Yun yung hanapin natin such that a sub n minus a has magnitude less than epsilon. And again, we usually do this via a preliminary analysis. Okay, hold on. Okay, preliminary analysis. So usually here we want to write, gusto nating isulat kung ano yung gusto natin makita. So here, for all epsilon greater than 0, we wish to find a natural number n such that for all little n greater than or equal to that natural number n, it follows that this inequality is true. Ito yung absolute value ni a sub n minus a ay less than epsilon. A sub n is 1 over n. Okay. Tapos yung supposed limit ay 0. So kaya napalitan siya ng 0 doon. So here we are considering this inequality. Absolute value of 1 minus n, 1 over n minus 0. Pag sinimplify, 1 over n lamang yan. Gusto kong masabi na si 1 over n ay less than epsilon. Ito talaga yung gusto kong final product. Mapakita na yung 1 over n ay less than epsilon. Pero, paano ako makakakita ng capital N that can guarantee this inequality? Yun yung nagiging problema natin. How can we choose or how should we choose capital N to ensure the satisfaction of this inequality? Ito yung gusto kasi nating maipakita later dun sa proof. Ang 1 over little n ay less than epsilon. Kailangan kong pumili ng capital N that can ensure this as long as little n is greater than or equal to capital N. Okay? Now, the idea here is, dahil preliminary analysis pa lang naman to, hindi to part ng formal proof. So, pwedeng, okay, paglaruan ko to, 1 over, si little n, dapat ay mas malaki kay capital N. So, baka posibleng piliin ko na yung 1 over n ay maging mas maliit sa 1 over capital N. Let's see if this will work. I decided to take a look at this inequality because direct consequence yan ng part ng assumption dun sa relation between little n and capital N. Okay? Kasi nga si little n dapat mas malaki or equal kay capital N. So, playing with this inequality, I'll get this. Okay? And you see na, mukhang enough na pala to. Nang 1 over n ay mas maliit kay 1 over n. Kasi kapag ka ito ay totoo, alright, which we know it is, okay? So ngayon, pwede kong i-impose na dapat si 1 over n ay gawin kong less than epsilon, or I will force that 1 over capital N ay less than epsilon. Kasi kapag ka si 1 over capital N ay mas maliit kay epsilon, as si 1 over capital N ay greater than or equal sa 1 over little n, then this and this will imply that 1 over little n ay less than epsilon as desired. Okay? So, kaya nasingit yung 1 over capital N dun sa gitna ng inequality. Kasi di ba pag nagsosolve tayo ng inequality, napaka-unnatural na nag-i-insert tayo dun sa gitna. Pero in the preliminary analysis, that's fine because we are looking for a condition on capital N that this will be true. Naghahanap tayo ng capital N. Ano kaya dapat yung property ni capital N para mapalabas natin to in the final proof? So parang nag-work backwards tayo rito. Dinadaya natin yung proof. Naghahanap tayo ng paraan, ano yung pwede kong ipakita na capital N para maging totoo tong inequality na to. Ang alam ko lang, si little n ay greater than or equal kay capital N. So that means 1 over n, kasi nga yung sequence ko ay 1 over n yung itsura. So why not from here get an inequality that involves 1 over little n? Tapos ito yung nakuha ko. Tapos yun pala, kapag ka si 1 over n prinersa ko na maging mas maliit kay epsilon, then this inequality will hold. The only question that remains now is, valid ba or lagi ba merong capital N na magiging less than epsilon? Okay? So yun yung tanong. Yun yung kailangan nating i-justify before we will be set to write the formal proof. Kasi nga, ang na-discover ko ngayon, as long as I can force that capital N is a natural number chosen so that 1 over capital N is less than epsilon, then we're done. Okay? Pero can I do this? Kasi remember, si epsilon ay isang arbitrary positive number. So if I give you an epsilon that is greater than 0, is it always guaranteed that you can find a capital N that is a natural number such that 1 over capital N is less than epsilon? Posible ba yon? Kahit anong epsilon yung ibigay ko ba sa inyo, gano'n man yun kaliit, laging may mag-exist na capital N na yung 1 over capital N ay less than epsilon? Sige nga. Aha. Yes daw sabi ni Ayesa. Bakit Ayesa? I-Ayesa mo na yung tatanungin ko, David, kasi nakapag-recite ka na. All right. Thank you, Ayesa. That's perfect. Ayesa said in the chat, by Archimedean principle or by the Archimedean property. So balikan nyo si Unit 1. Meron dong Archimedean principle na sabi kahit ano pa yung epsilon greater than 0, lagi kang may mahanap na mas maliit na number dyan sa epsilon na yan. And which is fascinating because sabi mo si epsilon kahit gaano kaliit. Kahit gaano pa kaliit si epsilon, sabi ni Archimedean property, lagi ka pang may makikitang mas maliit na number dyan. At sino yon? 1 over a sufficiently large natural number. Okay? And that's basically the crux of the proof here. Okay? That n is chosen to be the natural number guaranteed by the Archimedean property such that 1 over capital N is less than epsilon. Okay? Now, okay, with everything set, lahat ng ingredients nasa table na, so isulat na natin yung formal proof. What we did is just a preliminary analysis. You can include it in your work. Pag pinag-prove ko kayo ng limit ng sequence, pwede nyo isama yung PA o yung preliminary analysis pero hindi required. Okay? Ang kagandahan lang kung isasama nyo siya tapos medyo may mali dun sa proof nyo, pwede kong i-check yung prelim analysis. Baka naman dun lang kayo nagkaroon ng konting pagkakamali. Nag-propagate nga lang siya dun sa formal proof. Okay? But if you're confident with your proof, no need to write a preliminary analysis unless I specifically told you to do so. Okay? Okay. Now, how does a proof of a limit look like? So, sundan natin yung binigay dun sa lecture notes. First, you issue the challenge. You let epsilon greater than 0. Okay? So, kumuha ka ng epsilon greater than 0. At the back of your mind, this could be anything smaller. Okay? Now, tapos, di ba, ano to, challenge response game ito. Nagbigay na ng challenge na epsilon, kailangan magbigay tayo ng response n, anong response n. Alright? Pero, hindi na tayo mabibigla. Kasi dun sa PA, nahanap na natin yung candidate capital N. Now, okay, pwede ko nang ibigay yung response natin na nakuha natin sa PA. So, we take n to be the natural number such that n is greater than 1 over epsilon. Okay, so ito yung nakuha natin sa PA, pero sure na tayo na si capital N ay nag-exist kasi nga nag-guarantee na siya ng Archimedean property. So if you will be doing a similar argument, okay, maganda na ilagay nyo sa proof nyo, wag nyo nang i-parentheses, tanggalin nyo na siya sa parenthetical remark, ilagay nyo na siya na the existence of which is guaranteed by the Archimedean property. Okay? Kasi mahalaga yon. Kasi tatanungin kayo, okay, kung yan yung criteria mo kay N, sure ba ako na laging may capital N na nakakasatisfy niyan kahit ano pa yung epsilon na ibigay ko? Baka naman mag-work yan for some epsilons but not for all epsilons. So that would be a big problem. So include the reason why you can say that may natural number N na nakakasatisfy neto. Okay, and then now, pwede mo na ipakita na kapag si little n ay mas malaki kay capital N, yung inequality involving epsilon will be true. Okay? Now again, for all little n greater than or equal to capital N, and we're checking this because we mentioned that our business here is looking at the tail end of the sequence. So sa lahat ng mga indices na mas malaki kay capital N, gusto nating ipakita na totoo yung inequality. All right? And again, you don't start with the inequality. Bawal yung mag-start ng a sub n minus 0 minus a less than epsilon. Halimbawa, ganito nyo susulat. Malito ha. Maminusan ko na kayo pag ganito nyo siya sinulat. Tapos nag-substitute ka dyan. 1 over n minus 0. Nilagay mo kagad less than epsilon. Tapos 1 over n less than epsilon. Tapos sinabi mo na ang epsilon ay what? Actually, hindi mo pala siya ma-work out kung ganito yung gagawin mo. Kasi from here, where will you go? Okay? Ang alam mo lang ay 1 over n ay less than ang 1 over capital N ay mas maliit sa epsilon. So really, you cannot start from what you want to show. Okay? malulos kayo kahit ganun yung gawin natin. So you always start with one side and try to deduce the other side of the inequality. So here I started with a sub n, a sub n minus a. Tapos sinimplify ko lang yan 1 over n. Okay? But again, nakuha na natin sa prelim analysis. 1 over n. Ano yung pwede kong masabi about 1 over n? The only thing I know is that n is greater than or equal to n. So from this inequality, okay, alam natin na 1 over little n ay mas maliit or equal sa 1 over capital N. So I will write that. Tapos dito na papasok yung criteria na napili natin para dun sa capital N. We have chosen capital N earlier to be the natural number that is greater than 1 over epsilon. But if you play with this inequality, bearing in mind that n and epsilon are both positive numbers, so we'll see that 1 over capital N is less than epsilon. So pwede mo na ma-conclude from here that that would be less than epsilon. Okay? So essentially what you have shown here is that the absolute value of a sub n minus a is less than epsilon, which is basically what is required in the definition of the limit of a sequence. So you can conclude that the limit statement is correct. All right. Any questions? Okay, so kung wala naman, ano tayo, 2-minute health break. So stretch muna. So kumusta naman guys habang nagbe-break tayo? Officially yata nag-start na yung dry season. Though umuulan, umuulan pa rin, pero super init, no? Kapag nalingilan ng init, ay super init. Luckily before, nung nag-aaral ako, hindi ako umuwi sa Pilipinas ng March or usually umuwi ako every July and August. So, umuwi ako para magbakasyon dito. Tapos, ang ganda nung timing kasi tapos na yung SEM ko ron. So, SEM break kami. Uwi ako dito para sa SEM break. Tapos babalik ako before the next semester begins. Ang kagandahan ay sa Texas ay super init naman ng June, July. Okay? Tapos, para makatakas sa init ng Texas, uwi ako sa Pilipinas. Tapos pagparting July na, medyo amihan season na, no? So, kaya medyo okay siya. Tapos pag December naman, minsan super lumalamig sa Texas. Tapos dito, Christmas season naman, which is very festive. So, naisip ko, I cannot miss Christmas in the Philippines. So, ibang-iba talaga. Kaya yun, first time ko ulit magsa-summer dito sa Pilipinas. Ganito nga pala dito na super init.
Sir,
Yep.
Kinailangan niyo po ba ng like heater pag nasa Texas kayo? Kasi di ba parang medyo desierto po Texas?
Kinailangan naming mag-heater, kailan nga ba? Nag-heater kami ay kasi inabot kami nung winter storms. So kung nabalitaan nyo, last December or 2 Decembers ago, actually twice na nag-winter storm sa Texas na ang pinakamalala ay yung last December. Hindi pala tong last kasi nakauwi na ako nitong last December. 2 Decembers ago, talagang nag-snow sa Texas, which is basically one in a century event. So nag-freeze lahat ng electrical lines namin. Siyempre, kinailangan na namin mag-heater, pero hindi siya nagtagal kasi nag-brownout na, nag-blackout na sa malaking portion ng Texas kasi nga yung infrastructure nila ay hindi ready sa snow. Nag-snow bigla sa Texas. So, yun yung problema. Pero yeah, umabot kasi yung temperature doon siguro umabot siya ng mga 9 degrees Celsius. So yung iba nag-heater na. Pero sa apartment namin, Hindi kami nag-heater kasi ang saya namin kasi malamig. So yung ganong scenario. Pero definitely ang aircon doon ay parang all year round na bukas siya. Kasi nga super init. Pero na-miss ko na yung fall season doon na tipong 15 to 20 degrees Celsius. Ang sarap maglakad sa paligid. Tapos yun pa yung pwede kang fashionista kuno. Susuot ka ng layers. So, dito sa Pilipinas, pag nag-layers ka, basang-basa ka na ng pawis, hindi ka pa nakakalayo ng bahay. So, yun. So, yun. Tapos na yung commercial. Nag-overshare na naman ako. Pero anyway. So, let's see. Next example. Limit ng n plus 1 over n. So again, if you want to have a hypothesis kung saan magko-converge yung n plus 1 over n, pwedeng sulat mo yung first few terms ng sequence. I don't know if we can glean some information from there kasi computational na to. So n equals 1, we'll get 2. Sabihin niyo kung mali yung substitution ko, mahina ako sa math. 2, n equals 2, we'll get 3 over 2. N equals 3, we'll get what? 4 over 3. Tapos 5 over 4. 6 over 5. 7 over 6. And so on. Okay? So 2, 1.5, 1.3 bar, 1 point what? 1.25? Tama ba? Ito ay something, ito ay something, and so on. So, ganun yung mangyayari. Pwede nyo siyang ipa-plot or ipa-plot yung real function counterpart ni n plus 1 over 1, n plus 1 over n. Pa-plot yung x plus 1 over x sa inyong paboritong software. Or just try to look at an analysis of this. What happens when n becomes very, very large? Huwag muna kayo mag-L'Hopital's rule, huwag kayo mag-Hitch theorem kasi bawal nyo pa siyang gamitin. So i-analyze nyo lang to. What happens when n becomes very, very large? When n becomes very, very large, the numerator becomes very, very large, denominator becomes very, very large. Large number divided by a large number, no conclusion can be made. Kaya nga na-invento yung L'Hopital's theorem sa 30 series, right? Pero a little analysis or a little algebraic manipulation of n plus 1 all over n will tell us that it can be written as 1 over 1 over 1 plus 1 over n. Tama? So, tapos, ano yung mangyayari kapag si n palaki na ng palaki? Pag si n ay palaki na ng palaki, yung 1 plus n, paliit na ng paliit. Little enough that it will go to 0 later. So magzi-zero yan in the long run. So basically, it will just be 1 plus a very small number that tends to 0. So essentially, we're expecting that this will go to 1 really. Okay? Yung limit ng n plus 1 over n ay papunta kay 1. Okay. Now, pag may hypothesis ka na, i-prove na natin yung hypothesis. And we will do this by definition again. Tapos kailangan ko ulit ng preliminary analysis. Okay? Now, we will be given a challenge epsilon, okay? And we want to find a capital N such that for all little n's greater than or equal to capital N, gusto natin yung inequality na ito ay maging less than epsilon. So how can we force the issue that this guy is less than epsilon? Though may spoiler na rito, tingnan natin paano nabuo yan. Well, of course, dito ka magsimula. Sa prelim analysis, laging kukunin mo yung a sub n minus a, absolute value niya. Okay, this is the n term of the sequence. This is the claimed limit. Okay. And then, of course, this is a subtraction. It screams, simplify mo ako. Simplify nga natin yan. Ito yan. And luckily, we're back to absolute value of 1 over n. And since this is familiar, just from the previous example, we can borrow the same trick we used there. Okay, so gusto kong 1 over n ay epsilon. I can achieve that because I know that little n is greater than or equal to capital N. So this guy 1 over little n, ay sure ako less than or equal kay 1 over capital N. And again, the Archimedean property will allow me or will guarantee the existence of a capital N such that this inequality is true. Okay? Tapos so palang piliin si capital N to be the natural number or to be a natural number such that 1 over capital N is less than epsilon, the existence of which is guaranteed by the Archimedean principle. Okay? Tapos pag itong 1 over capital N ay mas maliit na kay epsilon, okay? Si 1 over N mas malaki yan kay 1 over little n. So we are sure that 1 over little n ay magiging mas maliit na kay epsilon. Okay? So I hope that preliminary analysis is straightforward enough. It was nice because nauwi na naman tayo dun sa Archimedean principle. Okay? Dun sa 1 over n. So the proof is very similar to the preliminary analysis and to what we did in example number 1. So sulat natin yung proof. Okay. We let epsilon be greater than 0 arbitrary. So yan yung template nyo. Simula kayo dun sa challenge. Epsilon greater than 0. And then by the Archimedean principle, we know that there exists a capital N such that N is larger than 1 over epsilon. Actually, parang ang statement natin ng Archimedean principle ay ito, no? Kung tama yung pagkakaalala ko, 1 over n is less than epsilon, which I think is better because this is exactly what we need in the inequality that will follow. Tama? Okay, so then after mong ibigay yung capital N, i-assume muna sa little n ay mas malaki kay capital N. And that is true. Nasa definition yon. Yun lang mga little n na mas malaki kay capital N, yung kailangan makasatisfy ng inequality na an minus L ay less than epsilon. Okay? So it's safe to assume this, that capital N is greater than or equal to, or little n is greater than or equal to capital N. Oh yeah, thank you, David. Yeah, small n yung na kay AP, pero yung small n na yun ay arbitrary natural number pa rin. So, parang pwede natin siyang palitan lang ng capital N. Alright? Kasi nga, existence niya lang naman. Hindi ko lang maggamit yung little n dito kasi ginamit ko siya dito sa mga subscripts. Pero that's fine pa rin naman. Alright? Ang sinasabi lang kasi nung Archimedean property natin doon, kahit anong epsilon greater than 0, there exists a little n in n such that 1 over little n ay less than epsilon. Hindi ko na nga lang magamit yung little n kasi ginamit ko siya dito sa sequences as subscripts. So lahat ng little n dito, pwede ko lang palitan ng capital N. And the statement still holds true. Alright? So parang semantics lang. Pinalitan ko lang yung variable, yung placeholder dun sa chapter 1. Okay? Tapos yun, ulitin nyo lang basically what you did in the prelim analysis. Start ka sa a sub n minus a. Simplify mo yan. Makikita mo rito. Tapos, oops, 1 over n. Alam ko na mas maliit yan sa 1 over capital N because of this assumption. Okay? And then, since we have chosen capital N nice enough such that 1 over capital N is less than epsilon, then we are done. Because here we have shown that this guy is less than epsilon as required by the definition. So there you go. We are done with the proof. All right. Okay. So here are some exercises that you can try doing. Okay. Prove the limit. I think yung proof neto at neto are very similar to what we did in the two examples. I'm just not sure about problem number 3. Okay, so probably you might want to start with exercise 3. Try nyo nga siyang sagutan and then let me know kung nagkaroon ng problema. If you will need some advanced technique, let's see. Hindi ko ma-imagine yung proof ngayon. Hindi ko sure kung magkaka-problema or hindi. Pero try it out. I guess you'll just need to do some rationalization. And essentially, this will, again, boil down to 1 over epsilon. 1 over epsilon. 1 over capital N. But I'm not sure. Kindly check on that. All right, so simulan nyo sa number 3. And let me know next time if you encountered some problems with it. All right? So we can discuss it in class. Because I want to end with the definition of divergence, okay, which is definition 3. So we say that the sequence does not converge. Or in other words, it is, mali pala, ulit, take 2. So we say that the sequence that is not convergent or that does not converge to be a divergent sequence. So yung sequence na hindi nagko-converge, siya ay isang divergent sequence. Okay? Or we say it diverges. Moreover, we say that ito na yung negation ng definition ng convergent sequence or ng limit ng isang sequence. So we say that the limit of a sub n is not equal to a if and only if we can find an epsilon small enough such that for all capital N, all right, lagi na lamang yung a sub n minus a ay greater than or equal kay epsilon naught. So, ibig sabihin, kasi yung definition ng limit for all epsilon greater than 0. So, kapag ka ang limit niya ay hindi equal kay a, therefore, may makikita kang epsilon greater than 0 such that even if you are in the tail end of the sequence, you can always find a term in the sequence with a large enough subscript that the distance between a is greater than or equal to epsilon sub 0. Okay? So, yun yung negation. So, hindi, yung limit niya hindi magiging equal kay a kapag merong kahit isa or may makikita kang epsilon greater than 0, epsilon not greater than 0, such that meron kang makikitang term ng sequence with a large enough subscript that its distance from A is larger than epsilon naught. Okay? So, ibig sabihin, hindi naglalapitan lahat ng mga elements nung tail end ng sequence kay number A. Kasi nga, sa lahat ng capital N, laging meron nag-exist na A sub N of a large enough subscript na malayo mula kay A. Okay? So, an example would be this alternating sequence. Yung sequence na -1 to the power n. So pag nilista natin yung mga elements niya, ito yung makukuha natin. -1, na wala yung braces. 1, -1, 1, -1, 1, -1, 1, and so on. Okay? Our claim is that the limit is not equal to 1. Okay. Bakit? Kasi sasabihin ko ay, hindi magiging 1 yung limit kasi may makikita akong epsilon, okay? Such that kahit nandun na ako sa dulo ng listahan, meron pa ring a sub n na ang layo mula kay 1, okay? Dun sa supposed non-limit ay mas malaki dun sa epsilon na yon. Okay? Now it's easy because I can just take epsilon to be, say, 1. Okay? Paano ako nagka-idea ng epsilon ay gawing 1? Actually, I could have chosen epsilon naught to be any number less than or equal to 1. Kasi tingnan niyo yung itsura ng mga nasa listahan, right? Magkakalayo sila by 2 units. All right? So actually A sub n, yeah, 2 units yung distance nila. So, posible pa lang, pumili ako ng kahit anong number, hindi lang mas maliit kay 1. Pwede akong pumili ng kahit anong epsilon naught na mas maliit kaysa kay 2. Kasi ang distansya sa pagitan ng dalawang consecutive terms ng sequence ay equal kay 2. So, ibig sabihin, kahit nandun pa ako sa dulo ng listahan, ang dalawang magkasunod na terms ng sequence ay may distance na 2. Medyo may exemption lang kapag nandun ako sa even positions, 0 yung distance nila. Okay? Pero ang claim ko lang naman ay si 1. Okay? Tapos si 1, i-compare ko na lang siya dun sa mga negative ones. Okay? Now, how will we write that analysis? Well, note na sa kahit anong capital N, that is a natural number, may makikita akong little n. Kasi dapat sa lahat naman ng capital N, may makikita kang little n such that etong distance na to ay mas malaki dun sa napili mong epsilon kanina. Nakapili na ako ng epsilon. Ang epsilon ko ay 1. So kailangan kong ipakita sa kahit anong capital N na natural number, laging may mag-e-exist na little n na yung inequality na to ay magiging totoo. Alright? So, ang epsilon ko ay 1, ang supposed limit ay 1. So, titingnan ko ano yung mga little n na pwede kong piliin. Now, hindi ko pwedeng piliin yung mga even na subscripts little n. Kasi kapag yung subscript ay even, ang a sub n ay nagiging 1. Tapos 1 minus the supposed limit, that is equal to 0. Okay? So, hindi magiging totoo itong inequality na to. Kasi nga, that is equal to 0 and 0 is not greater than 1. Okay? So, kailangan kong piliin. And I can do that kasi ang hinahanap lang naman ay existence ng little n. Kailangan ko lang makahanap ng little n na malayo yung a sub n mula kay 1. Okay? Now, ganito yung trick. Oh, sige, piliin ko si little n to be any any odd na number that is greater than capital N. So maybe I can choose little n to be 2 times capital N plus 1. Sure ako greater than yan kay capital N. So here we have found a candidate for little n that is greater than n, pero it was chosen so that that number is odd. And you will see in a few moments kung bakit nga ba odd. Though nasabi ko na yun sa analysis kanina. Okay? So let's try. Kung ito nga si little n, computing nga natin yung a sub n minus a. Look at its absolute value and compare it with our choice of epsilon kanina. Okay? So a sub n minus 1, since n is odd, kapag ka-odd si little n, ang a sub n ay negative 1. So we'll have negative 1 minus 1. Oh, simplify mo yan, makukuha mo ay si 2. M2 is definitely larger than our chosen epsilon kanina, and which is required by the divergence definition. So therefore, dahil sa kahit anong capital N, nakakita tayo ng little n na mas malaki kay capital N such that this inequality is true, then the limit is not equal to 1. Okay? Now, if you want to prove that that the limit is not equal to negative 1, then you can employ the same strategy. All right? So, ngayon naman ang pipiliin mo ay yung mga even kasi doon mo siya gustong i-compare. Kasi nga negative 1, gusto mo siyang i-compare doon sa terms ng sequence na mas malayo sa kanya, which is 1. So, and nakukakuha ka naman ng 1 kapag ka even yung subscript. Okay? And then, it can also be shown that it cannot converge to any real number not equal to 1 nor negative 1. Kasi nga, dalawa lang yung posibleng values ng sequence, negative 1 at 1. So, impossible talaga na mag-converge siya sa isang number aside from 1 and negative 1. Kasi limbawa, pag kinlay mong limit ay 1/2, okay, pwede mong piliin na epsilon sub 0 ay si 1/2 because 1/2 is more than 1/2 unit away from 1 and negative 1/2. Alright? So, ibig sabihin yung a sub n minus 1/2 ay laging greater than 1/2 for all little n. Tama nga ba? Yeah. Laging mas malayo yan kay 1/2 by 1/2 units. So, hindi mo na kailangan maghanap ng little n kasi nag-work tong inequality na to sa lahat ng little n's. Mapa-odd, mapa-even, mapamalaki, mapamaliit na capital N. So therefore, we can conclude na walang real number ang posibleng maging limit ng sequence sa negative 1 to the power n. So we say that the limit does not exist. All right? So I think we will stop here, but you see that mukhang ang hirap ma-prove na divergent ang isang sequence kasi kailangan mo mapakita na hindi siya nagko-converge sa kahit na anong real number. Okay, and that's what we did here. Madali pa nga to kasi dalawa lang yung posible niyang maging limit, 1 or negative 1. None of them worked. And then madaling mapakita na hindi siya pwedeng mag-converge sa kahit anong real number different from 1 and negative 1. Okay? Kaya lang matrabaho pa rin. So next time or later, we will discuss a divergence criterion. ano yung mas madaling paraan para ma-prove ng isang sequence ay hindi magko-converge. Okay? But that's for next week. So, do you guys have any questions?
Sir, question
Alright.
po.
Sige. Go, David.
So yung small n po sa Archimedean property, arbitrary po siya, tama ba?
Hindi siya, nakadepende lang siya kay epsilon. Kasi ang sabi ng Archimedean property ay for all epsilon greater than 0, there exists an n in n such that 1 over n ay less than epsilon. Yan yung sabi ng Archimedean principle. Pero yung little n, nakadepende lang siya kay epsilon. So pag nabago si epsilon, posible mabago yung little n. Alright? Pero but in a sense, arbitrary siya. Arbitrary yung choice ng notation. So pwedeng piliin mo dito, palitan mo siya ng capital N na lang. Okay? Because this, wala naman little n involved dun sa statement ng Archimedean principle, so pwede mong palitan ng kahit anong variable yung little n. Pwede mo siyang gawing capital N, pwede mo siyang gawing capital X, and so on. Tapos pag ginawa mo siyang capital N, swak na yung Archimedean principle na yan para dun sa paggamit natin sa proofs ng limits. Right? So, hindi siya arbitrary kasi nakadepende siya dun sa epsilon. Pero arbitrary yung choice ng notation para kay little n. Okay, so I hope that's clearer.
Opo, sir. Thank you po.
All right, you're welcome. So if there are no more questions, then thank you guys for coming today. I hope you have a good afternoon today. Enjoy the weekend. Happy solving sa problem set. Just email me if you have some questions about it. All right. So let's meet again on Tuesday. Tapos I'll be happy to hear yung mga hinaings nyo about the problem set by then. All right. So okay guys, have a good weekend. Bye-bye. Yung mga nag-recite verbally, paki-comment pala. Salamat.
Thank you po, sir.
Thank you, sir.